Now, let us go to activity 3, DC power supply with IC regulator circuit. So here is the circuit. So we will connect it using the live multisync. Then we will set the potentiometer to increment of 0.01, 0.1, or that is 10%. Then set the AC source to 5 volts. Then after that, we will simulate the circuit, adjust the potentiometer, and then so that we will set the line current to 100 milliamperes. Then measure the filtered voltage, the dropout voltage, and the load voltage, and we will record it on the table below. Okay, so first thing we will copy the circuit. Okay, then open the live multisync, then paste it. Okay, so we can drag it in here. Okay, we'll need 3 multimeters, a power source of AC, AC power. Okay, close. We need this one B4B42. So we will search it all groups. 1B4. Okay. Next we need the capacitor, 1 microfarad, basic. We need the capacitor, we need the 1 microfarad. Okay. Next we need the cap electrolyte. So we can choose any. Set it to 1000 microfarad. So also we need LM785. So we will choose all groups. Search LM780. Okay, 5 CT. Okay, we need this 5 CT. Click OK. Close. Also we need a LED. Search it also. LED. All groups. Okay. Then we will select red. Also we need the potentiometer, which is the 33 ohms. Okay, so basic. I have this potentiometer. So I've realized that this one on the circuit is a potentiometer, so no other resistor here. So but according to the instruction, so we will set the or adjust the potentiometer, so there are no other resistors here besides this 33 ohms. So we will set that 33 ohms into a potentiometer, so we can select any other thing here. So yeah, close. Then we will adjust the value to 33 ohms, and then increment of 10% or 0.1. Okay, next we need the ground, so we need to ground the whole circuit. So we can ground it, you can only put one ground for the whole circuit. Okay, then we will now arrange it. Okay. First, we will connect the power source to this, to the one before. Okay. Next. So I think we need this one. And then we need this line. Connect to this one. Okay. Then connect the multimeter to this one here, and this one here. Rotate this one, and rotate this one. So now we can connect this LED. Okay, now we have the full circuit. Okay, so we will now show the finished. So I have here the full designed circuit. So I have adjusted it. Okay, so here it is. Okay. So now we will now adjust the font so that we can see what was going on here. Okay, black. Now for the first one, so we need to set uh, the line current to 100 milliamperes. So we have here the line current. Okay, so 119 milliamperes by adjusting the potentiometer. Okay, so let's simulate. Okay, so okay, we have the IRMS of 233 milliamperes at 40%. So let us see. So if we decrease it, the current tends to increase. So what if we will set it to 100%? Okay. So the minimum RMS that we can go down is this one, 119 milliamps. So okay, so we can record now the readings for the value of the filtered DC voltage, the dropout voltage, and the output voltage. Okay, so the filtered DC voltage is now equivalent to 5.057. Okay, so now 5.057, and then the dropout voltage is equivalent to 1.483. 1.483. Now the output voltage here, we have this 3.574 volts. 3.574 volts. Okay, so notice that if we add this one and this one, we will arrive to the filtered DC voltage. Okay, then next, okay, so we will increase the source to 6 volts, to 7 volts, to 8 volts, to 9 volts, up to 12 volts, and then we will repeat the same procedure to record the filtered DC voltage, the dropout voltage, and the out voltage, but we will set the line current to 100 milliamperes by adjusting the potentiometer. Okay, so let us now increase the voltage to 6 volts. Okay, so okay, let us rerun the simulation. Okay, so we have now a reading here of 300 milliamperes, so it is going down. So our problem here, it is not going down up to 100 milliamperes by adjusting only this potentiometer. So in order for us to achieve this line voltage, we need to change the resistor here, this 33 ohms. So I think we should increase the resistance. Okay, let us now put this one. I think we can go up to 500 ohms or 1000 ohms. 1k. Okay, let's now change this to 1k. Okay, so we can see that it is increasing. So we need to okay, we need to change it. Okay, this we should arrive to the right line current of 100. What is the problem? Okay, so let us wait for the reading to become stable. Okay, so are now recording 140 amps, milliamps. Okay, milliamps. So now 34. Okay, let us now rerun the experiment. Okay. So our LED is blinking. We have 1.96. I think we should increase the percentage. So we shall add. So we are now approaching 50. I think we can go up to 30. Adding 50%. Okay, the problem is it is not increasing. I think so we can go down. So we need to adjust again the increment. So I think we can adjust it to 2%. And run the experiment. Okay. So now we will increase 3% to 20 milliamperes. So we need to increase it. Okay. Need to decrease it. In order to decrease the current, we need to increase the percentage here. Okay, so we are now approaching 100 milliamperes. Okay, but it decreases so much. 9%, so we shall, I think we shall go for 7%. So I think we shall go for 1% increment. Okay, so we shall add 26 milliamperes. Okay, so we need to increase to 8%, I think. Okay, now so we have the 100 milliamperes RMS. Okay, so these are now the readings: 6.514, 6.514. Then the dropout voltage is 1.582, 1.582, and our output voltage is 4.932, 4.932 volts. Okay, so the same thing we will use for the 7 to 10 to 12 volts. Okay, then for the instruction number 5, we will replace the IC regulator of 7812, and then we will repeat the procedure for 2, 3, and 4 using table 5.4. So this is the table. So up to 18 volts. So now we'll now pause the stop this simulation and then replace this one by 7812. Okay, so 7812. Okay. So we will disconnect this one. And then we will replace it by this one. Okay, so let us now see what will happen to the circuit. Now let us simulate. Now, okay, so we have our 7812 CT, okay, and then this is the readings for okay. Okay, so we will set it. So for 12 volts, so we will set the voltage to 12 volts. Okay, so change it and stop the simulation. And then we will set this into the line current into 100 milliamps. Okay, let us now wait. Okay, so I think we should increase the percentage. I think it should go as far as 35%. No, no, no. I think 15%. Okay, shall add. I think 20%. So we have now this reading at 29%. Okay, so we have the 95, so we can also decrease this one. So 28. We have 98 milliamps. Okay, so 100 milliamperes. Okay, at 28%. So these are now the readings: 14.957, 14.957, 7, and then 3.088, 3.088, and then the output voltage is 11.86. So basically this circuit, this particular DC power supply with IC regulator circuit is a step down power supply. So we have this power supply of 15 volts, and then it's now supplied, or the output voltage, to 11 volts. So you can vary the voltage here by adjusting the potentiometer, okay, or the amperes, okay. So at different supply voltage, we can now arrive by using the circuit to a different output voltage at 100 milliamps potentiometer regulation. Okay, so that's it for the experiment number 4, activity 3. Okay.